This lecture is about the Cauchy Euler's differential equation. That what is the Cauchy Euler's differential equation and how to solve the Cauchy Euler differential equation. Now, the Cauchy Euler's differential equation of non-homogeneous part will be of the form like this: ax square y double dash plus bx y dash plus cx equals to g of x. If this term on the right hand side g of x, it is equals to non-homogeneous. If this is non-homogeneous, then the equation is called non-homogeneous. And other than this, what is Cauchy Euler's equation? It is the equation that the degree of the coefficient must be equals to order of the derivative of every term on the left hand side. That on every term on the left hand side, the degree must be same as the derivative. So this is the degree and this is the derivative, so it must be same. If it is same, and here you can see this is the degree is 2 and the derivative is also 2, and here the degree is 1 and the derivative is also 1, so that's why it is called a Cauchy Euler differential equation. And what will be the homogeneous Cauchy Euler differential equation? If this term on the right hand side it is equals to 0, then it is called the homogeneous Cauchy Euler differential equation. Now in this lecture, we are going to see the third order homogeneous Cauchy Euler differential equation, how to solve this. That the equation will be of this form: ax cube into y triple dash plus bx square into y double dash plus cx y dash plus cy equals to 0, where these a, b, c's are the coefficients or the constants. Okay, and we can see here the power of x is 3 and here the derivative is also 3. Power is 2 and the derivative is also 2. So that's why it is a Cauchy Euler differential equation, and it is homogeneous because on this side it is the right hand side of the equation is equals to 0. Now in order to solve this, we are going to first consider that y is, let us suppose that y is equals to x power m, and if we want to take its first derivative, m will be coming here, so m into x power m minus 1. The second derivative will be of this form: m into m minus 1 into x power m minus 2. And similarly, because we are going this equation given is of third derivative, so we have to take 3 derivatives of y. So we will get the third derivative equals to m into m minus 1 into m minus 2 into x of x power m minus 3. So similarly, we will get the auxiliary equation for the equation number 1. It will be equals to that we are going to just substitute the values of y, y dash, y double dash, and y triple dash in the given equation number 1. So after substituting all these values, we are going to get of this form. The equation will be of this form: a m into m minus 1 into m minus 2 plus bm into m minus 1 into m minus plus cm into plus d equals to 0, where ax is not equals to 0. And there are 3 cases we are going to see. It depends on the roots of m, whatever the roots of m we found. So if the roots of m are 2 real and distinct, and we are going to write the complementary equation, or yc equals to c1 into x power m1, c2 into x power m2, where m1 and m2 are 2 distinct real roots. If the roots are 2 distinct, means they are different and they are real. So we are going to write the yc, the complement of c will be equals to this. And in the case 2, if m1 is equals to m2, so both the roots are same and they are real also. So we are going to write the equation or the complementary form of the equation as yc equals to c1 x power m plus c2 x power m to ln of x. Third case is when the roots are complex, and we are going to have in the form of lambda plus minus mu into iota. Then we are going to write the solution as x power lambda c1 cos mu ln of x plus c2 sine mu ln of x. So this will be the third case. So we are going to see the first question related to this, that find the solution of the following differential equation. So we have to see the differential equation first. That we can see now the derivative and the power, they are same. So this means that it is a Cauchy Euler's differential equation, and it is of order 3, we can also see, and this is homogeneous because the right hand side the equation is equals to 0. The first thing is that we are going to suppose that y is equals to x power m is the solution of the equation number 1, and then after that we will find the derivatives. The first derivative of this will be m into x power m minus 1. Similarly, we find second derivative and third derivative of this solution, and after that we substitute these y1, y dash, y double dash in equation number 1, whatever the question is given. So we substitute in that and we get the required solution or required equation in this form, that it will be x cubed. And what is y triple dash? It is equals to m into m minus 1 into m minus 2 into x power m minus 3. Similarly, x multiplied by y dash, whatever we have found y dash, and minus y we have supposed that it is x power m. After that, we just take this xm because all are there. So we take it as a common, and inside it will be m into m minus 1 into m minus 2, then m and minus 1. So similarly, x power m cannot be equals to 0. So this means that this other term will be equals to 0. So we put it as equals to 0, and then similarly we just multiply them and simplify them to find the factors. So it will be of the form m cube minus 3m square plus m minus 1 equals to 0. And this is actually the same as the trigonometric identity, that is equals to a minus b whole cube. So a is here, we can say m, and b is minus, or b is 1. So after that, we are going to have m minus 1 whole cube is equals to 0. So this means we are having the roots, they are same, and it is equals to 1. So m1 is equals to m2 is equals to m3 equals to 1. So this is actually the case number 2, which we have just studied in the previous slide. That so the solution of the given differential equation will be written as yc is equals to c1x, because all are same. So we are going to write as first will be c1x, then c2x, but it will be multiplied by ln of x, and the third root will be written as c3x ln of x power square. So this is the required solution for the Cauchy Euler differential equation, that is the homogeneous differential equation. Now in the question number 2 also we can see that how this is also the Cauchy Euler differential equation, because this power and the derivative is also same, minus 6 x cube into y triple dash minus 6y equals to 0. This we termed as equation number 1. This is a Cauchy Euler differential equation because the degree of x is equals to the order of the derivative. So we suppose again that y equals to x power m is the solution of equation number 1, and then we find similarly y dash, y double dash, and y triple dash, and then substitute in equation number 1. After substituting, we are going to have like this in this form, that it will be x power 3 into m into m minus 1, m minus 2 into x power m minus 3 minus 6 into x power m. And after that, we are going to see that we just factorize them, and in the end, we get the factors as m square equals to minus 2 and m minus 3 equals to 0. So this means this will be m3. This is the third factor, it is equals to 3, and these two factors will be plus minus square root of 2 and plus minus square root of minus 2. So it will be making it as iota, a complex number. And here, but we can see that this is mu, this is I, the iota part, and this is mu, but lambda here, we don't have any lambda, there is no constant here. So this is equals to 0, and mu is equals to square root of 2. And with that will be iota. Actually, this is the case number 1 and case number 3. So this is for the case number 1, that it is having distinct root, but here this m1 and m2, they are the complex roots. So the solution of the given differential equation will be of the form like yc equals to x power lambda and c1 cos of mu ln x plus c2 sine of mu ln x plus c3 x power m3. So m3 is here 3. So we are going to substitute this. It is equals to 3. And here lambda is 0. We can see it over here is 0 and mu is square root of 2. So just substitute the value of mu. Here is also mu. Ln of x will be as it is and lambda is equals to 0. So we will get it is equals to 1. So x power 0 will be 1. So the answer will be C1 cos of square root of 2 ln x plus C2 sine of square root of 2 ln x plus C3 x cube. So this is the required solution for the Cauchy Euler homogeneous differential equation.